I'm going to make a video about the polynomial CFU. This is designed for folks who had trouble with parts of it and need to do a do-over. So I'm going to go over how to deal with some of the problems. First I'm going to start with 1A and 1B, and then I'll make a video for other parts. So in 1A and 1B, we are combining, we're adding and subtracting parts of a polynomial. Basically, we're trying to combine like terms, like the 3x cubed and this negative 3x cubed. We've got to do something to combine this x and this negative 2x. So we're going to put it all together. So then we need to organize it in standard form, which means to organize it in decreasing degree order after we've combined all the like terms. Then we need to identify it using the degree and the number of terms. So let's start off by simplifying it. That's the first step, because you can't do any of the other stuff until you've simplified it. So when I look at this, first thing I notice, I've got these two polynomials in parentheses, and they're being added together. I have an x, something x cubed term, I have another x, I have a constant term over here. I also have a constant term here, a cubic term, a square term, and an x, or a first degree term. So the x and the negative 5x and the negative 2x, those are all first degree or linear terms. So the first thing I'm going to do, we're going to go down the order, because this will help me put it in standard form. So the first thing, I'm going to look for the highest degree over here. I have a positive 3x. I look for the highest degree over here. I have a positive 3x cubed. And I have a negative 3x cubed. I don't have any other terms that have higher degrees. So the highest degree I've gotten here is cubic. I'm adding between these two sets of parentheses. So I'm going to combine the 3x cubed and the negative 3x cubed. Now, I'm going to go ahead and write this in here. 3x cubed plus negative 3x cubed. Okay, so I've got that part. Now you might already notice that those will cancel out. Well, let's just do this systematically. Now I look, do I have any square terms, any second degree terms? I don't there, but I do have one here, and that's being added, so I'll just add that, plus 2x squared. I had a bunch of linear terms. So I have x, I have negative 5x, so I've got plus x minus 5x, and then plus negative 2x. All right, then finally I look at my constant terms. I have a negative 2, and I have a positive 7. So negative 2 plus 7. So now we're going to go through and systematically simplify each one of those things. So these two are going to cancel out. So they're just going to go away. And I will just make the point by doing this. They're gone. That's just a 0. Now, so I've got 0 plus, now I've got 2x squared. That's the only square term I have. So I don't have to do any more. And I have x minus 5x, which gets me to negative 4x minus 2x, so that's minus 6x. And I've got a negative 2 and a positive 7. That makes a positive 5. Now my 0 goes away. Okay, so the 0 goes away. And the nice and convenient thing about doing this systematically by degree is I have organized it in standard form. I have my highest degree term first, my next highest degree term, and then my lowest degree term. So I have second degree, first degree, and 0 degree term. The highest degree defines the polynomial by degree. So we have a second or quadratic polynomial. So I'll say quadratic or second degree. And then the next thing is the number of terms. We have 1, 2, 3, which makes it a trinomial. Okay, so we have solved that one. Now let's take a look at the second one. Second one is slightly trickier because we're subtracting across here. So I'm going to look here. What's my highest degree over here? It's a second degree. Okay, what's my highest degree over here? It's a third degree. All right, so over here, there's no third degree, so I'm really doing like 0x cubed minus 2x cubed. So I'm just going to say 0x cubed just to keep track of the fact that I didn't have any. And then I'm going to say subtract minus 2x cubed. Okay, now I look for my next degree. I have an x squared. Okay, since this is the beginning of this, that's going to be a positive x squared. And I look over here, do I have any x squared stuff over here? Well, I've got minus negative x squared. Well, minus negative x squared, we know that's going to end up being like adding. Okay, then I'm going to look here, do I have any other x squareds? That's all I've got. So now I'm going to look for my linear terms. Negative 4x, okay, minus, do I have any x terms here? Minus negative 7x. Okay, once again, we're going to have minus a negative, which is going to be like adding. Now I'm going to look for linear terms. I get a negative 4. Do I have a linear any here? Okay, so I'm going to be minus, because I'm going subtracting this polynomial from this polynomial. So minus negative 6. And that is all the pieces I've got. So this part here I can simplify now. We'll sign there for minus. We're continuing to simplify. So 0x cubed minus 2x cubed is just going to be 2x cubed. And now I've got x squared minus negative x squared, which is going to be x squared plus x squared. So plus 2x squared. And then I've got negative 4x minus negative 7x. That's really going to be negative 4x plus 7x, which is going to be plus 3x. And then I've got negative 4 minus negative 6, so that's going to work out to be negative 4 plus 6, so plus 2. And I have conveniently, by systematically going by degree, I've conveniently organized it into standard form. Highest degree is third, so it's a third degree or cubic function. Cubic or third degree. And I have more than 3 terms, so 1 term would be monomial, 2 terms would be binomial, 3 is a trinomial. Beyond 3, we just call it a polynomial. We could say 4-term polynomial if it is important to know how many. And yes, I misspelled polynomial. All right, so to review, first step is to notice what operation is between these two polynomials. Then systematically simplify, starting by organizing things from the highest degree, what combinations we've got. In this case, addition. In this case, we're subtracting from one polynomial to another. I organized things. I took the highest degree first, then I looked in this one and this one, found the next one and the next one and the next one until I got down to 0 degree or constant terms. Then I laid it all out together, paying attention to what my operation is and what my signs are. Same thing here. I laid it all out here together, paying attention to what my operation, subtraction in this case, and what my signs were of everything that I'm organizing. And then I combined all those like terms, which I had conveniently organized right next to each other. Please watch out for those like terms. That's one of the biggest things that was getting people. Finally, I simplified it. If I had simplified it a little differently, I might have had to rearrange things. So the highest degree is first. The highest degree is the power, if it's just a single variable, or the total number of sum of powers at the monomial term. The term has more than one variable. So if that was negative 2x cubed y squared, the degree would be 5th degree because 3 plus 2 is 5. But in this case, the degree is 3 because I've got x to the 3rd power. So I'd organize it in highest degree to lowest degree. The highest degree term, which we call the lead term, defines the degree of the polynomial. In this case, it's cubic. In that case, it was quadratic. Okay, cubic can be called third degree, quadratic can also be called second degree. And then I count the terms after it's been simplified. 3 terms makes a trinomial, 2 terms would make a binomial, 1 term makes a monomial, and anything more than 3 is called a polynomial, and it's useful to name it. Oftentimes a 4-term polynomial, a 17-term polynomial, etc. And I hope this has been helpful.